Hey, it's Neil from Gradesavers, and today we're doing question number 43 from section 7.2. Let's begin. The question reads, what is the integral of sine x cos x e to the sine x dx? And they would like for us to use an appropriate u substitution first before we use the integration by parts formula. So let's first select our u for our u substitution. We will let u equal sine x, which means that our dx is simply equal to du over the derivative of what we chose for our u, which is cos x. And now we can begin our substitution. So our integral reads, sine x can be replaced with u, cos x cannot be replaced by u or dx, so we can leave our cos x in place, and e to the sine x becomes e to the power of u, and dx is replaced by du over cos x. And we see here that this cos x and this cos x here will cancel out, so the integral that remains is simply the integral of u e to the u du. And now we can use integration by parts. In order to do so, we will use the formula here, and we will need to select another u and v. And for clarity, I will call it u1, since we already used a u here. u1 will be equal to simply u, and everything else that remains will be our dv1. So dv1 will be equal to e to the u du. Now, in order for us to find du1, we simply take the derivative of this, which will be 1, and stick on a du. And 1 times du is simply du. In order to find v1, we need to find the antiderivative of e to the u, or integrate this entire term, and that will simply be e to the u. And now we can put our formula together using integration by parts. So this means u times e to the u du is equal to, and according to this formula, u times v, or for us, u1 times v1, so u times e to the power of u, minus the integral of v1 du1, so e to the u du. And for clarity, this was u1, this was v1, minus the integral of v1 du1. And now we can begin further evaluating this integral here. First part, there's really no simplification that can be made, so this remains u times e to the power of u minus, and this integral is simply e to the u. Since we have no more integral signs and this is an indefinite integral, this is a good point to add in our constant c. Now that we have everything here, we're done finding all our integrals. Since we started the question with a substitution for u, we should do a back substitution. So what this means is wherever we see a u, we should replace it with sine x. So our answer should be sine x e to the power of sine x minus e to the power of sine x plus our constant c. And this is the answer to the integral of sine x cos x e to the power of sine x dx. And that's it for the final answer. Hey, thanks for watching. Grab the PDF from below, and remember, the best way to study is to join the Gradesavers review sessions.